Good morning. Thank you for attending this presentation. Today I'm going to present our research work, which is titled Enterprise Architecture Capability Profile for Software Use. To do so, I'm going to follow this presentation plan. First, I will introduce our research work, the research objectives, questions, and also the faced scientific problem. Then we present the proposed solution, which is the Enterprise Architecture Capability Profile Framework with its proposed meta model and its different processes and an example of the implementation work, and conclude with future work and the latest publications. Information systems are the combination of people, information technology, and business processes to accomplish a business goal. Information systems have to be agile and evolve quickly to support business processes in a relevant manner, and these business processes can be assisted by software tools and enterprise applications whose objective is the automation of the exchanges in the business environment. To respond quickly and effectively to opportunities, these business processes need to be adapted. This might be done by taking advantage of previous development and reuse components from organizations' internal and external solutions, such as open source softwares, to facilitate the development of complex systems with controlled costs. And these organizations also need to integrate the targeted system within and across the organization boundaries, and service-oriented architecture is emerging as a powerful paradigm for the integration and also for its several advantages, such as the loose coupling, the building of distributed software systems, and also the standard-based concepts. In this reuse context, Black Duck for Open Source and Innovation released in 2017 a study that was sent to practitioners, consumers, and contributors of open source solutions. And over 800 people responded to the study, spanning industries from manufacturing and retail to technology companies. And they found that 86% of practitioners reported that they have increased their usage of open source solutions for several reasons. The most important ones are the lack of vendor lock-in and the availability of source code. However, and besides the benefits of using open source software, practitioners are facing several difficulties in searching, evaluating, retrieving those technical components, in addition to the uncertainty of their quality. Therefore, and with reference to the presented research context, we aimed in this research work to target the following objectives. First, defining a software capability profile that describes capabilities from several perspectives, to establish a common foundation for managing and share all the artifacts produced during the qualification process, and to propose or define an exploitation model and exploitation plan to reuse all those qualified technical components in order to produce a ready-to-use application. In order to achieve these objectives, it requires answering the following fundamental research questions. For instance, how to identify initial requirements and architecture artifacts used to guide the development of existing solutions, or how to define mapping rules from end-user requirements to capability profile to support the development of new systems. To summarize all these research questions, the main research problem that the research addresses is how to manage the complexity of the exploitation of internal and external software capability profiles based on an alignment of requirement engineering and architecture process to select the best candidate components to act as a building block in new system. Therefore, to respond to these different problems, we have proposed these research directions. For instance, to consider a process which includes requirement engineering and enterprise architecture for formalizing the requirements, or to improve software capability profile that exists in state-of-the-art, to bring the value in use for an organization to reuse these technical components, or to shape a mechanism to identify the most suitable software to overcome the use of ad hoc methods. In order to attain the different objectives, we have proposed this architecture framework, which is composed of three processes. The first one for qualifying existing solutions. The second one, which is the enterprise architecture knowledge repository, to organize all those produced artifacts in order to facilitate their use in the exploitation process, which is the third process in this framework. in order to produce a ready-to-use application that reuses the different artifacts already qualified in the enterprise architecture knowledge repository. So regarding the first process, which is the qualification process, we realize bottom-up qualification enabling to produce a wider view qualification that results in an enterprise architecture capability profile. The second process, which is the enterprise architecture knowledge repository, it takes the produced profiles from the qualification process and with the usage of semantic annotations based on specific design ontology that offers a standard vocabulary and a formal language to reason about the annotations tags and organize the produced artifacts. And finally, regarding the exploitation process, it carries out the discovery and exploitation of the company's solution in an engineering process based on requirements engineering and enterprise architecture that results in a set of technical components and a ready-to-use business application that meet expressed needs. For this, we have proposed first a meta model that the qualification process, the different organization of the different artifacts, or also the exploitation process will be based on, and we take several concepts from the enterprise architecture, which is TOGAF framework, from business process model notation, volume specification for the requirements engineering part, regarding the software quality with the ISO 25010 or also the Microsoft Application Architecture Guide. And we have produced this meta model that is composed of 6 packages. First one is the application package. The second one is the solution building block package, which is a physical representation of the application package, and which is linked to the application building block, architecture building block, which is a functional representation of a solution building block, and which is linked to the organization package that brings the value in use for a company by describing the business goals and objectives that helped an organization to develop this technical component. We have first instantiated each building block of the meta model that we have proposed, enabling to create this model to facilitate the generation of an enterprise architecture capability profile and later on the enterprise architecture knowledge repository. So profile, when we generate it, it is filled following a bottom-up approach, first with the application model to describe the different targeted software, the interfaces, the implemented set, and so on. And for instance, to describe also the exposed services that we aim to reuse in the future. This artifact is linked to what we call the solution building block, which defines the implementation that fulfills business requirements. Then it is linked to an architecture building block which captures architecture requirements from business point of view, data, and so on, and which is linked finally with an organization model to bring the value in use to an organization and different stakeholders by describing the different business objectives and goals. Once we produce this capability profile, we enrich it with annotatic annotations. And for this, we have based on ontologies that enable to address the challenges mentioned about the creation of a repository for knowledge management and information retrieval. And this enterprise architecture knowledge repository provides standard vocabulary for the produced capability profile, preventing semantical problems and establish a common foundation for sharing contextual knowledge. And it provides a formal language to reason about software semantic annotation tags. For the design of this ontology, we considered the use code sankings methodology for the design of the EICP, what we call the EICP onto. First, by defining the scope, where we have defined several competency questions and analyzed the relevant entities. Then identify existing ontologies. We have selected ontologies that cover some of our domain needs and that are well defined, consistent, and reused in other projects. For instance, a top-level ontology, which is the BFO ontology, and domain ontologies, which are, for instance, TOGAF, OLS, BPMN, and EO ontology. Then we have integrated and extended these existing ontologies in a coherent way by managing the foundational and domain ontologies. And finally, we evaluate the consistency of the produced ontology using the fact++ reasoner that we will see just after. So regarding the integration and extension of existing ontologies, we have realized an alignment of top-level domain classes, which are EAO, TOGAF, EICP, OLS, and BPMN under the BFO ontology. And we have added 30 additional classes and are inserted in the NCP ontology based on the proposed meta-model. And we enrich the ontology with semantic axioms to define in a concise way classes and the different relations. And finally, we have completed the definition of the NCP ontology with textual annotations that aim to give the users more detail about the ontology components. And finally, as you know, reasoners enable to verify the consistency and detect unsatisfiable classes, and we have used the fact++ reasoner, which is among the most popular reasoners. And we have, regarding the test coverage, we requested the targeted solution by the identified competency questions in the first place. Finally, regarding the exploitation process, so how we are going to exploit all those artifacts to produce ready-to-use applications. So we have proposed this exploitation process, which is composed of 4 phases. The first one is phase A, where we define the scope of the as-is situation, identify the organization units that will be affected by the architectural changes, and identify the stakeholders, define the different goals and objectives, and so on. Then, in the second level, we describe how the enterprise needs to operate to achieve the business goals. And each information is used to check in the repository the different artifacts that are resent to a user to see in real time all the different artifacts that exist to this level of requirement definition. The third phase, which is the information system architecture, which is composed of 2 subphases. We have the data architecture, where we define the properties of each business data involved in the business functions that we have defined in phase B, and also define the technical requirements and infrastructure constraints. And finally, regarding the final phase, we define the technology architecture artifacts, such as information for the deployment phase, the environment where we want to target the final solution, and define also the non-functional specifications, which are very important. And with all those informations, that will help us to refine, identify the different existing solutions in the repository, and generate a targeted system based on the different solution building blocks that were identified in phase D. So we have proposed an implementation of the exploitation process of this EACP framework as a web application. So we have in the right side of this screen a screenshot of the different inputs needed, for example in phase A, that will be refined in different phases to identify the different artifacts that may be reused and generate the targeted business application. So you can find this implementation work in these GitHub repositories, and I have presented also and have prepared also some videos which are technical presentation and use case for the exploitation process that you can attend in these URLs. To conclude, this research work provides the enterprise architecture capability profile framework in response to the exposed research problem, and it is built on top of proposed meta model for the design of an advanced software capability profile able to be directly mapped to end-user requirements, and it assists and guides companies in the qualification and organization of their different assets, and in the definition of requirements and exploitation of qualified solutions to maximize their use. And we have proposed finally an implementation and an industrial use case covering the various problems. As research perspectives, in short term, we want to evaluate the composition of the different solution building blocks to meet requirements and constraints and minimize the development effort in case where there is no solution building block identified for the defined requirement, and also connect our repository with an external one, such as programmableweb.com, and exploit it in an efficient manner based on the proposed exploitation plan. and in the long term go beyond semantic annotations and try to propose new paradigms that will treat data, resources, and software as abstract elements without loss of information and applicable in different domains. Regarding our latest publications, we invite you to see the last publication that were already published in Enterprise Information System journal. Thank you very much for your attendance, and this is my contact information. Don't hesitate if you have any opportunity or postdoc or research fellow position. I will be glad to discuss with you and see if there is some possibility to work in your organization. Thank you very much.